Welcome to Mathematics Legend. 10 seconds before the discussion will begin. For mathematicians, the floor. Teach them. A proof in mathematics demonstrates the truth of a certain statement. It is therefore natural to begin with a brief discussion of statements. A statement or proposition is the content of an assertion. It is either true or false, but cannot be both true and false at the same time.
For example, the expression "there are no classes at Texas A&M University today" is a statement since it's either true or false. The expression "do not cheat and do not tolerate those who do" is not a statement.
A logical conjunction is an operation on two logical propositions that produces a value of true if both statements are true and is false otherwise. The conjunction of P and Q, denoted by P and Q, is precisely defined by
First blood.
Similarly, a logical disjunction is an operator on two logical propositions that is true if either statement is true or both are true, and is false otherwise. The disjunction or logical OR of P and Q, denoted P or Q, is defined by: if P is true and Q is true, P or Q is true. If P is true and Q is false, then P or Q is true. If P is false and Q is true, then P or Q is also true. If P is false and Q is false, then P or Q is false.
Double kill.
So now we're going to discuss about negation. In mathematics, a negation is an operator on the logical value of a proposition that sends true to false and false to true. The negation or logical not of P, denoted not P, is given by: if P is true, then not P is false. If P is false, then not P is true.
The next method of combining mathematical statements is slightly more complicated than the preceding ones. It is connected to the notion of logical implication. The conditional from P to Q, denoted P implies Q, is mathematically true if it is not the case that P is true and Q is false. The precise definition of P implies Q is given in the truth table. If P is true and Q is true, it is true. If P is false and Q is true, it is also true. If P is false and Q is false, it is also true. But if P is true and Q is false, it is false.
Biconditional statement is an operator connecting two logical propositions that is true if the statements are both true or both false, and it is false otherwise. A biconditional from P to Q, denoted as P if only if Q, is precisely defined by: if the antecedent is true and the consequent is true, then the statement is true. The antecedent is true and the consequent is false, and the statement is false. If the antecedent is false and the consequent is true, then the statement is false. If the antecedent is false and the consequent is false, then it's true.
To wrap up everything that we had tackled, we need to construct a truth table for this compound proposition P implies Q and Q implies R. Our task is to make a truth table. The first thing we need to do is to identify how many number of lines needed with the formula 2 to the power of n. Since we have 3 variables, therefore it's 2 cubed, which is equal to 8. So we have 8 lines. Quick recap. Conjunction can be only true if both statements are true and is false otherwise. Disjunction can be true in all cases except when both statements are false. Negation, just the opposite of it. Conditional can be true in all cases except when true implies false. Lastly, biconditional can be true if both statements are false and both statements are true and is false otherwise. We hope you learn and enjoy from this video. Thanks for watching.